Right, in this video we're going to find y for each of the following gradient functions. We've got dy by dx is 9x squared, dy by dx is minus 8x, dy by dx is equal to 7, and dy by dx is 2x squared minus 6x plus 5. And what we've got to remember here is what we've got is the gradient function, and we want to find the equation where it has come from. So we know from our first video here that integral of ax to the n dx is equal to ax to the n plus 1 over n plus 1 plus c, provided n is not equal to minus 1. That's a special case which can be looked at later. Right, the first one, dy by dx is 9x squared. So applying this, y will become the integral of 9x squared dx. Notice the integral has two parts to its notation. This bit s sign here, elongated s, and the dx. You must write both bits in. So now applying this rule to this now becomes 9x to the 2 plus 1 divided by the new power, which is 2 plus 1. Now when you get a bit better at this, you probably won't write all these steps out. So we get 9 plus c, which is a constant integration, because this can come from many curves, a family of curves. So it's going to become 9x to the 2 plus 1, which is 3, divided by 3, plus c. 3 goes into 9 3 times, therefore we get an answer of 3x cubed plus c. dy by dx is equal to minus 8x. At this stage, it'd be best to think of it as y is the integral of minus 8x to the power of 1. I normally wouldn't write that in, but we'll just do it for the introductory questions. dx. Remember the use of brackets here and here, because it's the integral of all of this with respect to x. So that will become y is equal to minus 8x to the minus 1. Applying this, add 1 to the power, and then divide by 1 plus 1 plus c as a constant of integration. So that equals minus 8x squared over 2 plus c. 2 goes into that twice and into minus 8 4 times, so we end up with minus 4x squared plus c. Now we're going to do dy by dx is equal to 7. Now this one often causes confusion, but if you think of it as y is the integral of 7x to the 0 dx, now x to the 0 we know to be equal to 1. So this becomes y is equal to 7x to the 0, add 1 to the power, divided by the new power, which is 0 plus 1, which plus c, which gives me y is equal to 7x, we don't write the 1 in anymore, plus c. So you can see if you integrate a number, all you need to do is put in the variable alongside it. And then when you've got dy by dx is 2x squared minus 6x plus 5, like in differentiation, you just integrate term by term. So this becomes the integral of 2x squared, 6x to the 1 plus 5x to the 0, but because it's integral of several things, we put brackets around the function itself. Perhaps normally we wouldn't write this or this in. It becomes 2x squared plus 1 divided by 2 plus 1, so applying the rule of integration now, minus 6x1 plus 1 over 1 plus 1 plus 5x to the 0 plus 1 divided by 0 plus 1, and then add our constant of integration. So that becomes 2x cubed over 3 minus 6x squared over 2, and then 5x to the 1 over 1 plus c. And this now can be written as 2/3 of x cubed, 3x squared, 2 goes into 6, 3x squared plus 5x plus c. Now some people will be able to go straight from here to here in one go. A couple of things to note. If you integrate a constant, you just add in an x, you get ax plus c, the integral of ax dx, and then if you integrate ax to the power of 1 dx, then it just becomes ax squared over 2 plus c. These two sometimes cause a little bit of confusion. Okay, I hope you've understood this. It's been a video to show you how to do the reverse process of differentiation, which is called integration to various different types of functions. I hope you've understood, and I thank you very much for watching.